Good afternoon, sir. We are Group 2, and the topic we will be presenting to you today is about tapeits, sir. So, next slide po natin. Yan, okay. So, first, an overview about what are tapeits. So, in an internal combustion engine, a tapet, also called a valve lifter or cam follower, is the component which converts the rotation of the camshaft into vertical motion, which opens and closes the intake or exhaust valves. In this report, we will discuss about the valve tapets themselves, as well as its interaction with other integral parts that make up the valve operating system. So, in the next slide po, these will be the topics we will be discussing today. Next slide po. So, 2, 4, 6. These 7 will be the topic we'll be presenting today. So, first, the camshaft itself, how it functions, how it operates, and how it runs. The tapet assembly itself, how it is assembled and its parts. The solid lifter and its counterpart, the hydraulic valve tapets or lifters. The push rods that are connected to the tapets. The rocker arms that are connected to the push rods. And the valve springs themselves. These 7 will be discussed individually and by parts. So next slide po. On to the first topic, the camshaft.
Camshaft is a rotating object usually made of metal that contains pointed cams which converts rotational motion to reciprocal motion. Yun nga, yung camshaft is sa metal talaga gawa, and yung purpose ng camshaft is para magbigay ng movement sa valve. Siya yung tumutulak sa valve para mag-function yung valve. And next, camshaft are used in internal combustion engine to operate the intake and exhaust valve, mechanically controlled ignition system, and electronic motor speed controller. So yun nga, gaya nga nasabi dito na part siya ng internal. So hindi siya nakalagay sa internal engine na nagbibigay nga, gaya nga sabi ko, nagbibigay ng pagpalo sa valve. Siya yung pumapalo o yung pumiikot para magbigay ng movement sa valve. And merong 2 types ng camshaft. Yung flat tappet cams, yun yung usually na nakalagay sa bottom, and the roller cams, siya naman yung nakalagay sa top. Camshaft is a rod which rotates and slides against a piece of machinery in order to turn rotational motion into linear motion. This change of motion is accomplished by the camshaft moving further and closer from the axis of rotation as the camshaft is pushed in the machinery. Yun nga, and nakakunik nga siya sa rod. Ano na naman ba? Na yung camshaft nga is, yun nga, motion niya is ikot lang siya ng 100 times or 1,000 times. And may mga symptoms ng bad camshaft. Ito yung mga backfiring, popping, a cylinder misfire at flow in a very high RPMs, a loud tapping noise coming from the valve. Yung valve is tumutukod na sa piston. And yung hugis ng camshaft is para siya yung patak ng tubig. It's parang pointed. Then yung camshaft is merong mga lip, yung tinatawag na lip. Yun parang yung sukat ng yung lip. Usually yung lip, di ba, yun yung parang yung pagtaas ba, yung ganon. The more na mataas yung lip, the more na mas malakas or mas mahabang range na binibigay para mag-move yung valve. And that's all.
Okay po. Good day, sir. So, ang next na topic na itatakal natin is about the tippet or tappet assembly. So, ito na yung pinaka-heart nung lesson natin for today. Okay. Next slide. So, yun nga, literally speaking, ang tappets ang nagko-convert ng linear motion sa loob ng mechanism. So, basically, ito yung lifter or valve lifter sa valve operating mechanism. Kasi, yung camshaft na gaya sinabi kanina ni Sir Eduardo is naka-connected rotationally sa crankshaft. So, kailangan ma-convert yung rotation na yon into linear motion. So, tappet or tippet ang role is to convert the rotation into linear motion. Without tappets, the return spring valve system would have to remain in contact with the cam lobe directly. So, kung wala akong tappets, yung spring valve na nakakonect sa rocker arm na nakakonect sa valve is nakarekta or nakakonekta mismo diretso sa camshaft, which is dapat hindi and iniiwasan natin. So, next slide po. Okay. So, ituturo ko lang sa inyo kung ano ba talaga dyan yung tappet or tappet. So, ito yun. Ayan. Ito siya. Ito yung tappet. And then, makikita mo, ito kasi rotational yung movement niya. So, kailangan ma-convert yon into linear motion. So, ito yon. Kailangan ma-convert into linear. So, yun yung ginagawa nitong tappet. So, kung wala daw to, ibig sabihin, itong isang buong mechanism na to is nakarekta dito sa camshaft, which is hindi dapat. Kasi, ito, umiikot to 1,000 revolutions per minute. And kung nakakonekta ito rekta dito, napakalakas ng heat na magagawa niyan. And at the same time, hindi makakasabay yung valve mismo and yung mechanism na to sa pagtaas at pagbaba ng camshaft. So, dapat meron tayong tappet assembly. And at the same time, mostly, kaya kailangan natin ito is because napakalaki ng reduction ng noise and vibration sa engine kung meron kang matinong tappet or tappet. So, yun yung pinakamahalagang part sa ibang sasakyan kasi may mga sasakyan or may mga aircraft and may mga engines na design para sa comfort ng pasahero. Hindi dahil sa from point A to point B, kung hindi para sa comfort nila. So, malaking advantage ng may magandang tape. So, next slide. Okay, so, ito yung pinakaloob niya. Yan. Madali na siya tingnan, diba? Kumaga basic lang siya. Pero, lahat yan is may role sa paggawa or pagkakaroon ng magandang tappet. By the way, yung pinapakita ko sa inyo is hydraulic tappet, hindi solid tappet. Because mostly ngayon ang ginagamit is hydraulic na. Pero mamaya i-discuss naman yung solid lifters or tappet. So, next slide. Ayan. So, dito na tayo mag-focus. So, paano nga ba nagkakaroon ng, ano nga bang component na meron dito sa loob? So, kung makikita nyo, meron siyang spring. Ayan lang, lagyan natin ng... Meron siyang spring which is, kumbaga pansalo ng vibration and pangtaas nitong reservoir. Pangtaas siya dito. And then, meron tayong check valve spring dito. Ayan. So kapag naiipit to, nagsasara yung reservoir, which is merong oil sa loob niyan. Next is the check valve assembly, and then next is the enlarged flanger piston, body oil hole. Ito yung pinapasukan ng oil kasi ang hydraulic tappet hindi yan water, oil ang gamit niyan. So dito pumapasok yung oil galing sa oil lubricating system. So pagkapasok niyan, pupunta yun dito and then pupunta rin sa reservoir. So meron sa labas and then meron din sa loob. So next is the oil metering plate dito sa taas, valve spring, high strength push rod seat. Ayan. Ano yan? Yan ang nakakonekta naman sa sa papunta sa rocker arm. And then merong internal oil groove. Ito yung mga allowance na kapag nag-lock itong mechanism na to is dyan may ipit yung oil. And then merong tappet body, syempre yung katawan niya mismo. And then yun ang pinaka mostly na component niya. So next slide po. So ito na lang yung pinaka basic na paraan na ma-explain ko sa inyo kung paano nangyari yung hydraulic valve. Papasok yung oil dito sa loob, and then ito yung sinasabi ko na reservoir dito. Yan. Nandiyan mapupunta yung oil, and then ito yung sinasabing high strength na nakakonekta dito sa linya pataas sa rocker arm. And then kapag nag-push yung camshaft sa hydraulic tappet, maglalak ito, magpupush to pababa. So ang mangyayari, yung oil is maiipit, di ba? So yung naipit na oil is magsa-soften ng vibration. Yun. And then lalabas rin yung sa labas dito. Nawala na yung pressure dun sa camshaft. Lalabas yung oil dito. Yan, dito. And then yung mga oil dito is lilipat siya papunta dito sa dito sa side na to. So mababalance na yung system. Ang kagandahan kasi diyan is kung gaano kalakas yung balik ng camshaft. 'Di ba may rotating camshaft diyan na may point niya ganyan. Kung gaano kalakas yung bilis niya or gaano siya kabilis, ganoon din kabilis mag-adjust itong hydraulic tappet. Ayan, wala siyang specific na RPM or pressure na hinihingi para maggumana. Bumabase yung system niya sa lakas ng camshaft or sa bilis. So ang resulta nun, mas smooth and mas na-adjust na yung power or yung mechanism bago pumunta sa rocker arm. So sa pamamagitan nun is napalambot na yung system and mas nag-less ng vibration and mas naging efficient. Yan, wala masyadong vibration kung maganda ang hydraulic tappet mo. Yan, kasi 'di ba? Kung mas malakas yung bibigay ng camshaft, mas malakas din ang mapipigil na oil dito. Kasi itong oil na to is pag yan inipit mo, parang mag-act din siya as solid. So ganoon din ang mechanism niya pagdating sa baba. Mag-a-adjust din siya. So yun lang mostly ang pinaka simplest way na ma-explain ko sa inyo ang tappet. So ito pa lang na-explain ko is hydraulic tappet. And then mamaya na i-discuss yung solid lifters or solid tappet. So yun. Yun lang mostly ang introduction sa tappet. So next presenter.
Okay. So good afternoon po sir everyone. So I'm gonna be discussing the solid lifters or tappets. So next slide po. So solid lifters or cam followers are generally require the valve clearance to be adjusted manually by adjusting a screw and lock nut valve clearance is needed to assure that the valve has enough clearance in the valve train to close completely. These adjustments or inspection is continuous maintenance item until the hydraulic lifters were used. So, si solid lifters po is, as discussed kanina sa assembly, its main function is to transfer the oil from the lubricating systems all the way to the top of the engine. So, si solid lifters po constructed as smaller ones compared to the hydraulic lifters. Kasi po, main difference between the two is the hydraulic lifters has roller spring at the bottom, while solid lifters has flat end po, no. So sa solid lifters, it produces more friction compared to the hydraulic lifters, kasi as discussed na, yung hydraulic lifters has roller at the end, which causes yung camshaft to move faster and then makapag-open ng valve much faster and makapag-close din ng valve para makapag-combust dun sa part ng engine. So, ayun po, next slide. So as you can see, this is what we call the flat tappet. So ayun nga, yung basic components na to is meron siyang plunger retainer clip at the top, and then plunger cap as well, and then also it has spring in the inside and also yung body niya. Next slide po. Solid lifters, also known as mechanical lifters, are exactly what the name implies. They are solid pieces of metal between the cam lobe and the push rod. This type of valve train needs gaps between components that allow thermal expansion. These gaps are known as slash. So, si solid lifters nga po is also called mechanical lifters or flat tappets po. And since the solid lifters are used before, I can say mas efficient yung hydraulic lifters as of now, kasi it gives more RPM, while yung solid lifters kasi mabagal yung pag-transfer niya ng energy since connected siya sa push rod and then sa camshaft. Kapag mabilis mag-rotate yung camshaft, yung solid lifters is nahihirapan din mag-angat baba dahil nga sa friction na napoproduce nito. And then also, kaya may butas yung mga lifters natin, and is to transfer nga yung oil. So yung push rod meron din siyang butas, and then doon dumadaan yung oil. And that's about it for my presentation. Solid lifters.
So punta na po tayo sa counterpart po ng solid lifters po, yung hydraulic valve tappets or hydraulic lifters po. So, next slide po. So, hydraulic lifters automatically adjust or zero-lash value lifters. They have a spring-loaded plunger inside. As the engine runs, the body of the lifter fills with oil. The spring in oil allows the plunger to move up and down as needed. A hydraulic valve lifter is quieter than its screw adjustment type, have better lubrication, and basically maintenance free. However, it needs to have a certain amount of preload set installed. So, as discussed earlier, hydraulic lifters are basically lifters that have plungers in them that move up and down as needed when the camshaft or the cam lobes come in contact. This allows it to basically have no need to adjust it manually, or the lash distance between the lash of the tapered, sorry, the lash of the tapered itself. Every time sorry, the every time a flight is conducted, since it no longer needs to be done because it automatically adjusts to the length. And one other part why the hydraulic lifters are better than the solid lifters is because solid lifters usually expand thermally during operations. That's why a certain amount of distance is preset to accommodate that expansion. For hydraulic valve lifters, that is no longer a problem since oil flows and moves uh, around the inside of the hydraulic lifters, ensuring that a set temperature is always kept at level. This prevents the thermal expansion. So it's no wonder why hydraulic lifters were used more commonly now than its counterpart, the solid lifters. Though a small drawback in using hydraulic lifters is that a certain amount of preload is needed to be set when it's installed. But all of these benefits outweigh the single flow of the hydraulic valve lifters. So the benefits still outweighs the cons. So for now, we'll discuss how to set the preload and why is it important. Next slide po. So, sorry, right, here we go. So, the preload is basically the distance the plunger moves away from the retaining ring when a push rod or the push rod comes into contact with it. What this does is basically ensures that the lifter has enough space to move up and down. If the preload is set too little, it basically does nothing and is basically a solid lifter, as it basically does not move up and down as it did the plunger. But if set too high, the spring may be damaged and basically slams up and down instead of a squeaking noise for a plunger. So a preload must be set once installed to prevent those two occurrences. And if not properly set, it may result in the tape becoming damaged very, very quickly and becoming a dead lifter. So beyond that, the hydraulic lifter is basically maintenance free. Once it's installed, it's basically there until something breaks or in mandatory maintenance where it needs to be checked or replaced. But beyond that, it does not need any more attention because it by itself takes care of itself. So that's why hydraulic valve lifters are used more commonly now than its counterpart, the solid lifters. So next slide po. I think that's it for my topic. Yes. Okay. So basically, this is the hydraulic lifters with the cam connected to it and the push rod. So when the cam or the cam loop comes into contact with the tape, the cylinder, the plunger inside moves downward, and the spring comes into contact, which fills up the inside with oil that prevents it from which basically pulls in the oil and acts as a buffer and a, how you say this, dampener. Yes, dampener. And when the job is finished, meaning the oil, the cam lube no longer comes in contact with the tapeet, the oil is then flowed into the cam rod where the hollow point of it is lubricated inside, where oil flows into the hollow point. So that's basically what the tapeet does, essentially. So that's pretty much it on my part. Next topic po, ma'am. Next slide.
So, let's move on to push rod. So, next slide po. So, push rods are long, slender metal rods that are used in overhead valve engines to transfer motion from the camshaft located in the engine block to the valves located in the cylinder head. So, basically po, yung push rod natin is, siya yung nagtatransmit ng lifting force coming from our lifter, which is our tappet, to our rocker arm na yung rocker arm natin is siya yung, I think siya yung nag-open and closes nung ating valve. And yung push rod din po is hollow siya sa loob. So, ginagamit yun is for lubrication po. For lubricating yung sa bearings ng rocker arm and the steel ball dun sa ating mismong push rod. So, para ma-reduce yung friction between those things. So, I think, ano po yung akin. That concludes with my report. Thank you.
Okay, so the last two integral parts that we will be discussing will be the rocker arm and the valve spring. So first is the rocker arm. So this is how it looks like. So this is typically located between push rod and intake and exhaust valve. Okay, so its main function is to transmit the lifting force from the crankshaft to the valves. So dito siya located. Sorry. Yeah. So, from the name itself, rocker, pinupush and pull to ng push rod to rock up and down. So, ganun yung movement. So, of course, exhaust and intake valve won't function properly if ever na loose or broken tong rocker arms since we have one rocker arm per valve. So, ito rin yung nagsusupport sa firing order. So, if ever na masira siya, the cylinder will be disabled. Okay, so last is the valve spring. So this is how it looks like. So of course, its main function is to control the entire valve train. So connected to or nandun to mismo sa valve natin. So it ensures the proper amount of spring pressure is applied consistently since nabanggit nga ni Mr. Empalmado kanina, it rotates yung natin nagro-rotates ng 1,000 RPM. So, malakas yung vibration and prone yung metal natin to metal fatigue. So, nag-help siya para ma-lessen or ma-restrict yung vibration. So, we use 2 or 3 helical springs kasi if one spring lang yung gagamitin natin, so, magkakaroon tayo ng difficulty in retaining the vibration. So, each spring vibrates at different engine speed. So, it restrains or prevents all spring surge. So, what do we mean by spring surge? Yun yung sudden upward movement. So, we don't want that to happen. So, yun yung pinaka-main function niya. Because 2 or more springs reduces the danger of weakness and possible failure. Its main function as well is to hold the valve securely on the valve seat. So that's it.
So this is the entire system in motion. As the camshaft rotates, it comes into contact with the tapeits, which lifts up the push rod, which connects to the rocker arm, and then pushes down or pulls up the valves inside the cylinders. So this This cycle repeats itself hundreds, if not thousands of times in seconds or in minutes inside an engine. So, as you can see, if that is seen, I believe we have a video of that, I think. Friction and intense amount of friction and heat will be generated, no doubt. And wear and tear of objects or components will no doubt happen. So, to prevent that, constant flow of oil from the reservoir towards the push rods and to the rocker arms must be ensured, and that this system continues to operate on a regular and consistent basis, since this is basically what makes the cylinders operate. Without these systems operating at normal functions, the engine itself would basically not work or function. So always maintain the parts of the system in its peak condition. And that's basically it, sir. We are done with our report. We are group 2, topic about tapeheads. And mag-record ulit. And I hope that our report was satisfactory to you, and to whomever students that will be watching this. I hope that you learned something from us today as we reported this topic to you. So once again, we are group 2, and we are thankful that you gave us this opportunity to give this report to you, sir. So goodbye. Any last remarks from our reporters? None? Heart remarks. So, bye. Miss Anne, paki-end na
Sir,
po
thank you po.
Thank you.
Diesel engines was established in 1893 by inventor Rudolf Diesel. This animation describes the working principles of diesel engines in the context of an inline-4 engine that operates in a 4-stroke mode. This kind of engine has 4 cylinders mounted in a straight line. The camshafts operate the valves. In this animation, each cylinder has 4 valves, of which 2 are inlet valves and 2 are outlet valves. The fuel injection system is responsible for supplying the cylinders with fuel. The pistons are forced down during the combustion stroke. The force exerted on the piston is transmitted through the connecting rod to the gearbox. In an inline-4 engine, there is always one piston doing one of the 4 strokes. That is the reason why 4-cylinder engines usually run more smoothly than their 1- and 2-cylinder counterparts. A 4-stroke diesel engine has the same strokes as an Otto cycle engine: induction stroke, compression stroke, power stroke, exhaust stroke. Unlike the typical Otto cycle engine, a diesel engine takes only in air through the intake valves during the first stroke. During the second stroke, the intake valves are closed and the air is compressed. As the air is highly compressed in the cylinder, the temperature of the air rises and reaches almost 1,300 degrees Fahrenheit. In the third stroke, diesel fuel is injected directly into the cylinder. The fuel instantly ignites because of the high temperature of the air. The explosion pushes the piston down which transfers power to the crankshaft. The fourth stroke is the process where the spent fuel air mixture axes through the open exhaust valves and the stroke cycle is repeated again. A big advantage of diesel engines is that they typically deliver 25 to 30% better fuel economy than similarly performing gasoline engines.